Hello everyone, welcome back in my class of mobile application and game development. We are in week number 6 and in this week our focus is on heuristic methods and searching techniques. This is part 3rd video lecture of week 6 and in this part our focus is on exploring A star searching techniques. In part 1 and part 2, what we did, in part number 1, we discussed pathfinding techniques, and in part 2, we discussed heuristic methods. So this we did in part number 1 of week 6, and this one we completed in part 2 of video lecture. And this week, that is in part 3, we are going to discuss A star searching technique for path finding. So in order to understand A star searching technique for path finding, I have given one example. The coding part you will complete during the tutorial session, and here I will explain you the logic, the concept of A star searching techniques. Let me show you the example. So here you can see this is the graph, and in this graph what we want to do, the task is, the activity which we are going to perform is, we want to start our journey from source A and our goal is to reach to destination Z. So this is my source point and this is the destination point, or you can say goal point. The circle represents the node, or we call it vertex, and the connection, the link between one vertex to another vertex is known as edge. So here you can see some weights are given on the edge, some value v is given on the edge, and some values are given on the vertex. So the value which are given on the vertex are the heuristic weight. And we call it heuristic distance of that node. So the heuristic distance of node A is 14. Heuristic distance of node F is 11. Similarly, here heuristic distance of node B is 12. Likewise for all the vertex. Here for Z, heuristic distance of node Z is 0. For this, it is heuristic distance of node E is 4. So like this, you can see the heuristic distance for all the vertex. So all the vertex or all the node have some heuristic weight or heuristic distance, whereas for the destination vertex or for the goal vertex, the distance, heuristic distance is 0. And our task is to reach from, we will start our journey from this point and we want to reach to vertex Z, that is destination vertex, and we want to travel minimum distance. This is the goal. This is the task we are going to perform. So in order to complete this task, what we will do, we are intended to apply A star searching algorithm. So in the next slide, I will explain how to apply A star searching algorithm. So this is the given graph. The green color vertex represents the source, or we call it current vertex. So in A star, if you are here, then this vertex is referred as the current vertex. So this vertex is my current vertex. If you are at this vertex, then this vertex will be your current vertex. If you are at this vertex, then this vertex will be your current vertex, and it will be represented using color green. Now what we'll do, we'll in order to organize this whole idea, I have created one table. So this table has some column. So the first column is for the node, second column is for the status, the vertex is the current vertex or visited or not visited. This is for the distance, this is for the heuristic distance, and this one is the total distance, and this one, the last column, is for the previous node information. So here you can see all the nodes are listed in the first column, A to Z. The current vertex is A, so A is my current vertex. Distance at this point, since we have not traveled anything, so distance at A is equal to 0, but heuristic distance at A is 14. So here the distance is 0, heuristic distance is 14. The total distance will be total distance. If you want to find out, then it will be the distance at the vertex, that is 0, plus the heuristic distance, that is 14. So we will get 14. So like this we will find out the distance, total distance, and since we are not reaching to a vertex A from any other vertex, this information is not given. So here previous node information is inputted. Now you can see from this graph, from A you can reach to two vertex A, B and vertex C. So here, since we are not reaching to any other vertex, so all the other vertex are represented as infinite. If you are writing the programming code, you will use the term undefined. I will explain this during the tutorial session. So this infinite is represented as undefined value in the programming, but here I have used infinite. So from A I can reach to vertex B and C. It is explained in the next slide. So here you can see from A the color is changed here. So B and C is now in process. So current vertex is A, here the distance is 0, total distance is 14. I already explained this, and this is 0 plus 14 will give you 14. From A, vertex A, I can reach to vertex B and vertex C. So vertex B and vertex C I can reach. Here if you are reaching to this vertex, then you are traveling 4 distance. So 4 is given here. If you are reaching to vertex C, then you are traveling 3 distance. So 3 is given here. Then what will happen? 4 is the distance you are traveling plus the heuristic distance at vertex B, which is 12. So 4 plus 12, it will give you 16. So we got 16. So 4 plus 12 will be 16. The previous vertex is A, that is this. Similarly for vertex C, if you will see, it is 3 plus heuristic distance is 11. This is given here. So 11 plus 3, it will give you 14. Now at this stage, what you will do, you will see which distance is the minimum distance. So here this distance is the minimum distance. So your new current vertex will be C, and it is explained in the next slide. So here you can see, now this is done, this is visited. Now the new current vertex is this, and from this vertex I can reach to vertex E and vertex D, and I will repeat the same process again here. So vertex C is my current vertex, I can reach to vertex D and vertex E. If I am reaching to vertex E, I am traveling 10, distance is 10, and this 10 is because if I am reaching to vertex D, then this 10 I got because 3 distance I used to travel from source vertex to E vertex, and 7 distance I am traveling to reach to vertex D from vertex C. So 3 is this distance and this 7 is this distance. So we got 3 plus 7 is equal to 10, and heuristic distance at this vertex is 6. So 6 is here. So 10 plus 6, it will give you 16, and the previous vertex is C. Similarly, I will evaluate the total distance for vertex E. So here 3 is this distance. So 3 is here, and the new distance we are traveling from moving from vertex C to vertex E is 10, which is this. So 3 plus 10, it will give you 13, and heuristic distance at vertex E is 4, which is given here. So 13 plus 4, it will give you 17, and the previous vertex is C. Now you have completed this, so we are left with this weight and this weight. So we will make a set 16, this is from here, comma 16, this is from here, and 17. So minimum is 16, but we have 2 times 16, so we can take any one. So I am selecting B. So now I will explore vertex B in the next slide. So here you can see now the vertex B is the source vertex, and from B I can reach to F and E, and same thing is explained here. So my current vertex is E, this one is visited, this one is visited. So from B I can reach to F and I can reach to E. So if you are moving to F, so 4 plus 5, that is 4 plus 5, it will give you 9. The weight, heuristic weight is 11, so 9 plus 11, it will give you 20, and the previous weight vertex is B. Similarly, if you are checking for vertex E, then 4 plus 12, 4 plus 12, it will give you 16, and the heuristic weight at E is 4, so it will give you 20. But earlier weight for vertex E, if you are reaching from C to E, was 17. So we'll see 17 is less than 20. So if the weight is less than the new weight, so we'll select the previous one. We'll ignore this new weight. This is what we are doing here. Now in the next slide, if you'll see, now here we have completed this. Now we are completing this. We completed this. So the new weights are 16, 17 and 20. That is this, this and this. So here the minimum is 16 and 16 is for D. So D will be my new current vertex, which is given here. So from D I can reach to E, I can reach to C. C is already visited, so I will not go back to C. I will check for E. This is what we are doing here. So current vertex is E. Here the weight is 10. So 10 plus 2. If you are traveling to this, it will be 2. Then 10. This 10 plus 2. This 7 plus 3 is 10. That is this value. So you got this value here. Plus you are using 2 distance to reach to E. So it will be 2. So it will give you 12. And the heuristic weight at this vertex is 4. So it will give you 16. And now 16 is less than 17. So we will update the weight. And the previous weight is D. Now we'll see for this vertex and this vertex. So 16 and 20, which one is the minimum? E is minimum. So my new source vertex will be E. And I will check the same process I will apply for Z. And then I will explore for E. So the total weight will be, so the path which I will follow is A. I will start from A. Then I will move to C. Then I will move to D. It is this. Then I will move to E. That is here. And then I will move to Z. That is my final destination. So this is how A star algorithm works. So you need to maintain a table, a list or table to keep the information about the weights, or you can say it may be cost, cost in terms of money, it may be distance, or it may be time. So these are the terms you can consider while working on A star algorithm. And here you can see this is the final path, and if you will add the total weight, then you will get 17 as a total distance or total weight. And this is 3 plus 7 plus 2 plus 5. So this way you will get the final weight. So that's all from my side in this session. Thank you very much.